My name is Linda Nan, and today for TED Talk, I will be talking about microbes and space. Climate change, global pollution, and overpopulation are factors that are driving our Earth to destruction. If these problems are not solved within the next century, our children will be faced with catastrophic consequences. As clearly shown through bioremediation, microbes can be used to help clean up our planet. Although bioremediation is a good start for saving the planet, it may be too late or not enough. Nevertheless, microbes are quintessential members of nature that we need to study in order to prepare for the alternative. Space. In order to prepare for space, there are three questions that we must address. The first question is, are other planets in space habitable? Will life on Earth be able to survive on these planets? And are there existing life forms on these other planets? To address the first question, is space habitable? In a press release as of last month, NASA's Kepler's telescope finding has shown to have discovered two new planetary systems, in which are in the habitable zone. The habitable zone is a range of distance from the orbiting planet to the sun or to the star where the surface temperature may be suitable for liquid water. The Kepler-62 system has 5 planets, and the Kepler-69 system has 2 planets. Kepler-62e, Kepler-62f, and 69c are the super Earth-sized planets, meaning they resemble Earth the most. Scientists do not know whether there are life on these planets. However, their discovery indicates that we are closer to finding other planets similar to ours. Now let's look at a closer planet to Earth, Mars. Through NASA's Curiosity rover's findings, its analysis of samples from Gale Crater, which is a stream bed found in Mars, has discovered that there are elements that are essential to life, such as nitrogen, sulfur, oxygen, and phosphorus. All these elements were found in these rock samples. Michael Myers, a lead scientist from NASA's Mars exploration, said with information NASA has now, suggests that Mars could have a habitable environment. However, this habitable environment may only be suitable for microbes that live in extreme conditions. Although Andrew Schrager from the University of Florida may say differently. He tested Serratia liquefaciens, which is a facultative anaerobe, meaning that oxygen is inessential to survival. This bacteria can live both in aerobic and anaerobic conditions. Hence, it can be found in multiple types of environments, ranging from in fish, plants, so on the skins of human beings. When exposed to harsh conditions similar to that of Mars, such as high carbon dioxide atmosphere, cold temperatures, and reducing pressures, the Serratia liquefaciens was found to be able to survive. Surprisingly, when extremophiles were exposed to the same conditions, they were not able to survive. Now, to address the third question about whether or not there are other life on these existing planets, we must look into our past, or shall I say, at the rocks from our past. In the studying of microfossils and meteorites, scientists have discovered nucleotides in these rocks that date back from 3.8 billion years to 4.6 billion years ago, hence during the Hadean eon. And in these rock samples, they found nucleotides suggesting these were remnants of bacterial DNA. The Hadean eon is an era in which the planet experienced heavy bombardments of asteroids and meteorites, and so lots of rocks hit Earth. In 1978, scientists discovered microfossils resembling yeast cells and fungi in a 3.8 billion-year-old quartz. Further analysis of other ancient rock samples indicated biological and photosynthetic activities due to the high presence of organic carbon and some calcium. These elements are residues of photosynthesis and oxygen secretion. Prior to moving out to space, we must be well versed in our extraterrestrial ancestors' history and how they were able to adapt and survive to new planetary conditions. Despite their microscopic size, microbes are pioneer space voyagers whom we should study and simulate their tactics as we prepare for the great space migration. In conclusion, if we do not restore our planet's health, then the generations to come will be facing catastrophic conditions, leading the human race to the verge of extinction. We must take action now. Every person has his or her own responsibility to be resourceful. Every scientist has their own responsibility to think outside the box to improve living conditions. And everyone must be mindful that if and when our efforts that we do today is not enough, we must prepare for tomorrow. In the words of Stephen Hawking, I don't think the human race will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet, but I'm an optimist. We will reach out to the stars. Thank you. Doo-doo-doo-doo.